Hi, welcome to Distance and Length. This is Claudia Carranza, and this is a video for my high school geometry class. We're going to be looking today at three really important items. We're going to be looking at the betweenness theorem. We're going to be looking at the segment addition postulate, and then finally the definition of midpoint. And the definition of midpoint is going to kind of create this new little definition for us. So stay tuned at the very end of the video for the kind of little hidden extra. Okay, so let's talk about the betweenness theorem first. The betweenness theorem says if a point is between two endpoints of a line segment, as you can see in our picture, you're allowed to add the distance from the point to one of the endpoints of the line segment to the distance from that same point to the other endpoint of the line segment. When you do that, you'll end up with the total distance of the line segment. Okay, next up we have the segment addition postulate. The segment addition postulate says that if B is between A and C, then the distance AB plus the distance BC equals the distance AC. This sounds a lot like our our betweenness theorem, but it's stated in this kind of algebraic sort of way, which allows us to write algebraic equations and then manipulate numbers on those actual distances. Next up, our definition of midpoint. Now we're going to have three different ones here, so stay with me on this. The first one says, if the distance of AB equals the distance BC, and that point B is between A and C, then B is the midpoint of line segment AC. Well, this kind of makes sense. I mean, if you have two line segments that are the same length, they're kind of stuck to each other. Well, then this point that they're stuck at has to be halfway between the two ends. The next part of the definition says, if B is in fact the midpoint of line segment AC, then line segment AB and line segment BC are congruent segments because their measures are equal. Remember, congruent means same shape, same size. Well, since their measures are equal, they've got to be the same size. And since they're both line segments, they're the same shape, so they're congruent. The last definition we have for midpoint says, if B is the midpoint of AC, then the measure AB is half of the measure of AC, the total. And BC is half the measure of AC. Again, that sort of makes sense because, well, the word midpoint sounds like it's a point right in the middle, which is exactly what it is. This definition of midpoint allows us to create a new word, a segment bisector. Segment bisector is a segment, a ray, a line, or a plane that intersects a line segment right at its midpoint. And that's it. We've gone over betweenness theorem, segment addition postulate, and the definition of midpoint with our little special hint of creating the definition for a segment bisector. Hope you enjoyed the little quick video. Thanks so much for watching, and we'll see you in class.